Sir, we are doing Rutherford.
Okay. So, Rimaisa, Avni, please turn on your camera. What we are studying? Last topic, can you tell me?
We finished Rutherford's, I think, sir.
Rutherford model. We finished Rutherford model. Na?
Yes.
Do we have written the drawbacks of Rutherford models and some other things?
No, sir.
No. Okay. Drawbacks of Rutherford model we have not written. Na? Do we have written the conclusions of Rutherford models and their observation? Tell me.
Can you repeat what you asked?
I'm asking that do we have written the instead of drawback, do we have written the conclusions of Rutherford model? Rumaisa, tell me.
Conclusion, yes, we did, sir.
Rumaisa, are you there?
Yes, sir.
Can you tell me the last topic that we have written? Can you tell me the last topic that we have written? Tell me. Avni, tell me the last topic.
Sir, I was in the last class.
You wasn't there in the last class. Why you wasn't there? Yes, Rumaisa, last topic. Tell me. Rumaisa, last topic.
Sir, we did write conclusion of Rutherford's experiments.
You did write the conclusions.
Yes, right, we did.
Okay, so tell me that what was the conclusions of Rutherford model? Yes, Dr. Jabbar, tell me the conclusions of Rutherford model.
Sir, can I bring that notebook, sir?
I'm asking that can
No,
you
sir,
tell me
can I
that
bring the notebook in which I wrote that?
you didn't wrote that one?
No, sir, can I bring the notebook in which I wrote it?
Okay, go on, go bring it. Yes, Rumaisa, can you tell me? Riaz,
Sir, can you please repeat the question?
yes, can you tell me the drawbacks of can you tell me that last topic that we have studied first? First, you need to tell me that last topic that we have studied.
Drawbacks.
Drawbacks of Rutherford model.
Yes, sir.
Okay. Can you tell me the conclusions of Rutherford model? What were the conclusions of Rutherford model? What were the conclusions of Rutherford model? Okay, noted down. The first was when we are just having this one. Okay, when Rutherford was doing his experiment, he found that in gold leaf alpha scattering experiment. This is the conclusions. Okay, let me explain you. Gold leaf. Okay, gold leaf alpha scattering experiment. Okay, experiment. First, he find that there were three conclusions. One was that okay, the first one was that most of the alpha particle passes through the gold foil without any deflection. Okay, most of the alpha particle passes through the gold foil without any deflection. Some of the alpha particles deviate at small angles. deviates, they were just deviating at a small angles. Okay, got it? And the third one was that out of 12,000, one alpha particles was not able to penetrate the gold foil, and it rebound back to its original path, and that is 180-degree. Got it? And it rebound back to its original path. Are you getting this one? Getting this one? What I'm saying here? That most of the alpha particle passes through the gold foil without any deflection. Okay, it means that atom is going to have lot of empty space. Okay, got it? Got it? The
Yes, sir.
second thing is that some of
Yes.
the alpha particles, some of the alpha particle deviated small angles. They were just moving like this, but they deviated small angle. What does it mean? That there is some charge particle, because actually helium particles are, yeah, or we can say that alpha particles are positively charged particle. Alpha particles are positively charged particles. Okay, alpha particles are positively charged particles. Got it? Got it? Got it?
Yes,
Understood?
sir.
So
Yes.
since alpha particles are positively charged particles, okay, and they are moving, so if there is some positively charged nucleus, so they will repel each other, because positive repel each other. And if there is some electron in the path of this one, so it will attract. So if this is the atom, and if the alpha particle is passing through this very closer to the nucleus, then it will rebound it, it will repel it, so it will deviate its path. Okay. And if there is some electron present here, let's suppose this is an electron, so it will attract it towards it because it is positively charged. So due to some positively and negatively charged particle, some of the alpha particle get deflected from their path. If they are moving straight, they are just deflected to small angles. Got it? Got it? Due to presence of electron and proton, which are positively and negatively charged. And the third point is that out of 180, out of 12,000, only one alpha particle were able to rebound back to its original path. It is not able to penetrate it, the gold fan. So what does it mean? That there is something very dense and hard mass present in the atom through which alpha particle cannot penetrate. Through which alpha particle cannot penetrate. Okay. Yes, you Riyaz, turn on your camera.
Sir, I couldn't find that notebook because I'm starting to write it in your notebook. I have not found.
Okay. So we can simply say here that there is only after 12,000, only one alpha particle is able to rebound back to its original path, indicating that there is some dense and very hard substance present in the atom through which alpha particle cannot penetrate. Okay, because nucleus is very hard, and he named it as that mass substance he named as nucleus. What he named as? He named as nucleus. Got it? Got it? Understood?
Yes, sir.
Now, note this one. And through which, note it down, that what are the most of the alpha particle pass through the gold file undeflectedly. Conclusion that there is a lot of empty space in the atoms. Second is some of the alpha particle deviate to small angles. There is some charged particle present in the atom through which alpha particles are deflected, is attracted or repelled. Third one is out of 12,000, only one alpha particle is rebound back to its original path. There is something, the conclusion, there is something very hard and dense present in the atom. Okay, which we call nucleus, through which alpha particle cannot penetrate. Okay, and there is, and all the mass, or we can all there is all mass of the atom is concentrated, and there is, and all is all the mass of the atom concentrated. Note Noted?
No, sir, 1 minute.
No, sir.
Noted fast. Yes, Riaz, are you there?
Yes, sir.
Yeah. Tell me, what does the first observation, what is the conclusion of the first observation? That most of the alpha particle can pass through the cold file undeflected. What is the conclusion? What is the conclusion? Tell me that if in the experiment Rutherford observed that most of the alpha particles passes through the cold file without any deflection. So what was the conclusion? What he concluded from this one? Tell me, Uta. Yes, you Avni, tell me what was the conclusion? The first one. Avni, are you there?
Yes, sir, I'm here.
Then why are you not answering?
No, sir, I couldn't hear your voice. Now only I heard.
Tell
So I
me.
should say conclusion of the first one, right?
Yeah. What
So
he's saying that most of the yeah. What is the conclusion?
the conclusion for the first one is the atoms between the particles have more space in between them, so that's why the particles are passed through it.
The simple is that atom is going to have a lot of empty space. Yes. Yes, Rumaisa, what is the conclusion of this observation that out of 12,000, only one of the alpha particles is rebounding back to its original path? What was the conclusion of that?
There is something very loud and dense substance present in the atom, that is the nucleus through which the alpha particles can penetrate.
Yes, you, Abdul Jabbar,
Yes, sir.
tell me that what was the conclusion of the second, that most of the alpha particles passes undeflectedly, but some of the alpha particles are deviated to small angles. What was the conclusion of that?
There are some charged particles present in the atom, so some alpha particles are deviated from the path and repelled.
So done. This one noted.
Yes,
Should
sir,
I
I've
move
written.
forward?
So, sir, I have to write it.
Yeah, write it first. Yes. Share.
Sir, you change the screen.
I know. There's a big damn. Share. All I have not saved a flag. Now I have to note it down again because I have not saved the slide. So have you noted that from the which point you have not noted? Tell me. I've rewrite it again. Because that slide has tell me
It's the last one.
the last one. Just a minute. The RAM is not free, that's why it is taking so much. Last points. The last point was most of the alpha particles out of 12,000, only one of the alpha particles was able to, out of 12,000, only one alpha particles is not able to penetrate penetrate the gold coil or or
Sir, just
it
read the
it
conclusion.
yeah, yes, it rebound back to its original original path. So conclusion, the down that what was the conclusion? That there is something very hard and dense present in the atom to which alpha particles
Sir,
can't
my
penetrate.
electric charge went, that's why I disconnected.
Okay. Okay, through which alpha particle cannot penetrate. Okay, and all the mass is concentrated in the nucleus. Note it down fast.
Done, sir.
Sir, what is written after rebound?
Rebound,
Yeah.
rebound back to its original path. Rebound back to its original path. Okay. This is the third one. Okay, the third conclusion. Now moving to the next part is that what are the drawbacks of Rutherford model? Actually, Rutherford give the model of the atom. Okay, and on the basis of this observation that Rutherford has given, okay, that the sum of the alpha particles moves undeflectedly, okay, without any deviation. Some of the alpha particles deviate at small angles, some of the alpha particles. So he gives several observations. Okay, so on the basis of his observation that Rutherford were making, or assumption that he was making, he gives the structure of atom. Okay, he gave the model of the atoms, and what he said here actually, he said that what he actually gives in his model that atoms in an atoms electrons revolve around the nucleus, okay, in a fixed orbit, okay, What he said? Electrons revolve around the nucleus in a fixed orbit. Okay, and and what he actually said that electrons revolve. Let you write it down here. That electrons revolve around the nucleus in the fixed orbit, and they do not uh, means we can say that they are just spiraling around the nucleus. Okay, they are. He said that electrons revolve around the nucleus in a fixed orbit. Okay, he only just give 3 points here. Let me explain you that what were the 3 points. Let me explain you first. The first point is that this is the nucleus and electrons are revolving. He said that electrons are revolving around the nucleus. Okay, so in a circular path in an orbit, which he called it orbit. Okay, got it? Got it?
Yes, sir.
And he said that there is hard mass means hard mass substance present in the inside the atom, which is positively charged. Okay, and electrons are revolving around it. And he said that the whole mass of the atom is concentrated inside the nucleus. Means the electrons are revolving, but they are not just having much mass. The whole mass of the atom is concentrated at the center, which is nucleus, which he called it nucleus. And nucleus is very, very small as compared to the size of the atom. So as we compare the size of the atom, the nucleus is very, very small because out of 12,000 only one of the alpha particles were rebonding back. So it means that that nucleus is very, very small in size as compared to the size of the atoms. So what he said actually, let me explain you that according to him, that what he gave the observations on the basis of the observation. So what is the Rutherford model? According to Rutherford, on the basis of the experiment, Rutherford proposed a model of the atoms having following features. So first of the feature is that there is positively charged nucleus. So note it down here. On the basis of his observation or experiment, Rutherford proposed the model of the atoms having following features. The first feature is that there is positively placed in the nucleus or positively charged particle or substance present in the atoms. We call it nucleus. Nearly all mass reside in the nucleus. Second point, that electrons revolve around the nucleus in well-defined orbit. And third, the size of the nucleus is very small as compared to the size of the atom. So note all these 3 points. Done?
No, sir.
No, sir.
Note it down, all these 3 points.
Only the keywords, right?
Not only the keyword, the whole statement you have to write. Done?
1 minute, sir.
Note it fast, everybody. You are writing very slowly. Written, Rumaisa?
Written.
Riyaz? Written?
Yes, sir, written.
Yes, sir.
Yes, sir. Done.
Okay. So tell me, Rumaisa, what are what was the conclusions on the basis of his conclusion? What Rutherford means? What he said in his model? What Rutherford said in his model? Turn on a camera. Yes. What Rutherford said? What was the structures? What he said about the nucleus? Especially what he said about the nucleus. In his model of
So he said that there is a positively placed nucleus in an atom and nearly all the mass resides in nucleus.
okay. Yes, Avani, tell me what he said about the nucleus size as comparison to the size of the atom. What he said? Avni,
Sir.
what he said about the size of the atom, so size of the nucleus as compared to the size of the atom.
The size of the nucleus is very small compared to the size of the atom.
Okay. Yes, you Riyaz, what he said about the electrons. Where does electrons lies in an atoms?
Electrons revolve the nucleus in well-defined orbit.
Yes, you Abdul Jabbar,
Yes,
tell
sir.
me what he said about the nucleus of the atom.
The nucleus are positively charged and they're very small compared to the this thing atom. All the
And
mass of the, this thing atom, nearly all mass resides in nucleus.
okay. Now, what is the drawback of the Rutherford model? Actually, according to the Rutherford theory, okay. So, sorry, according to the Maxwell theory, what he said, Maxwell theory. Maxwell was a scientist who gives his theory, okay, and he said that according to the according to the Rutherford, nucleus is positively charged dense particle present in the center of the atom, and electrons are revolving around it, and the electrons are revolving around it. And according to the rule of theory, Maxwell theory, when a charged particle revolve around an uncharged body or a charged body, it continuously release its energy, and it will take no time for an electron to collapse with the nucleus. It will take no time for an electron because electron is going to have very less energy. So it will take 10 raised to the power minus 7 seconds only for an electron to collapse with the nucleus, which is very small. That is 0.12345 6. This is very less. This is very less. So what he actually says that according to Rutherford, okay, electrons revolve around the nucleus, but according to the Maxwell theory, okay, according to Maxwell theory, that when a charged particle revolve around another charged particle, then it will radiate its energy. It will lose its energy. And for an electron, it will take no time, approximately 10 to the power minus 7 seconds to collapse with the nucleus. This make atom highly unstable. This make atom highly unstable, which in real life it does not happen. Okay, so this answer was not given by the Rutherford. So this is the major drawback of Rutherford model. So if I talk about it, what are the drawbacks of Rutherford models? Drawback of Rutherford model. Okay, so what are the drawbacks of Rutherford model? So according to Maxwell theory, according to Maxwell well theory of electromagnetism. Let it be well theory when a charged particle, okay, is go of me. According to Maxwell theory, when a charged particle revolve around an uncharged or charged body, it continuously radiates its energy. Thus, for an electron, it will take 10 raised to the power minus, it will take 10 raised to the power minus 7 second to collapse with the nucleus. So according to Maxwell theory, which make atom highly unstable. unstable. This, but in reality, it does not happen. So this he was not able to explain.
This is highly after atom.
Yeah. Highly unstable. Yeah.
Done, sir.
You also? So Riaz, tell me what is the drawback of
The,
Rutherford model? Mute yourself.
according to Maxwell theory, when a charged particle revolves around in uncharged or charged body, it it continuously particle will lose energy and finally will collapse with the which nucleus in 10 raised to this minus 7
Second.
minus seconds, which make atoms highly unstable.
Yes, you Abdul Jabbar, explain why what is the drawback of Rutherford model?
Sir, according to Maxwell theory, when a charged particle revolves around an uncharged or charged body, it continuously radiates its energy. Thus, for an electron, it will take 10 raised to the power minus 7 seconds to collapse with the nucleus, which makes the nucleus highly unstable. But in reality, it doesn't happen.
Avni, are you there? Avni. Okay. Now, after this one, Bohr was the one who came and who gave the model of his atom. Okay. What actually Bohr says? Bohr says that like we have just going to have the nucleus at the center of the atom and the electron revolve around it. What Bohr says that out of imaginary orbits, we can have infinitely many orbits. Okay, we can imagine unlimited orbits. We can imagine one orbit here, we can imagine one orbit here. So out of imaginary orbits, only there are some particular orbits where the electron can revolve. Like this is the first orbit. We just imagine this is the distance, particular distance, this is the first orbit. Now it is not necessary that this can be considered as second orbit. If it is not having the same radius or equal radius, which a second orbit is going to have, means the second orbit radius is fixed. So if it is the second orbit radius, then electron cannot revolve in this orbit. This will be considered as second orbit. So out of infinitely many imagined orbit, electron can revolve only in some orbits, which he called discrete orbit. Which he called? Tell me, discrete orbit. Okay, Avni, Vaisa there.
Yes, sir, I can know.
Turn on your camera. Okay. So out of imaginary unlimited orbits, infinitely many orbits, electron can revolve in particular orbits. Okay. And he said that whenever the electron is revolving in a particular orbit, okay, it neither gain its energy nor it lose. Means the energy of the electron in an orbit is fixed. Why? Because this is a positively charged and this is a electron that is revolving around this one. So it will continuously lose its energy according to the Maxwell theory. But he said that no, if it is revolving in a particular orbit, then it will not lose or gain its energy. It will neither lose nor gain its energy. Okay. So energy of electron in an orbit is fixed, he says. Third thing he says that there is a particular number of electron an orbit can have. For example, for the first shell, there is maximum number of 2 electrons it can have. For the second shell, it can have 8. So he gave this with a formula 2n square, where n is the number of shell, where n is the number of shell. Okay. For example, if I want to know that how many electrons the first shell can have, so we will write here 2n square means n is 1 for the first shell. It is 2 into 1 square is 1 is equals to 2. For the second shell, it will be 2 into 2 square, it will be 2 to the 4 and 2 8. Okay, this will be 2 into 3 square, so 3 square is 9, so 2 into 9 is equals to 18. In the fourth shell, it can have 4 square is equals to 2 into 4, that is 16 is equals to 32 and so on. But if it is the, just look at this, but if it is the outermost shell, if it is, the first shell can have maximum 2 electrons, the second shall have 8, the third shell can have 18, the fourth shell can have 32 electrons. Okay. So what he says actually, he says that out of infinitely many orbits, an electron can revolve in a particular orbit, which he called discrete orbits. Second point, he says that when electron revolve in its orbit, it neither gain energy nor it lose its energy. Third point, the very important point, he says that when an electron jump from one orbit to another orbit, like this, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and this is the third orbit. It is going to have 4 electrons. So if electron jumps, let's suppose this electron jump from this orbit to this orbit. So it will absorb energy, and when electron jump from outer to inner orbit, then it release energy. Okay, then it release energy. So what he actually says that electron, when it is revolving in a particular orbit, it neither gain energy nor it lose energy. I will ask you, when it is revolving in a particular orbit, it will neither gain nor it will lose. But when it jumps from one orbit to another orbit, then there is a change in the energy take place. If it is moving from inner to outer, then it will absorb. And if it is moving from outer to inner, then it will release. Got it? So note down the points here. Four model points. Note down that Niels Bohr 1912 proposed modified model of structure of atom. Okay. He made the following assumption. Only certain special orbit known as discrete orbits, electron can revolve and allowed inside the atoms. Second is this one, third is this one. Note it down.
Sir, so if it's jumping from one orbit to another, it will gain or it will lose.
Yes, there is a diagram for slide the 3 points, and here is the diagrams. That if it is losing, okay, here's the diagram. So when it jumps from inner to outer, that it is showing in this arrow. If it is moving from inner to outer, then it is absorbing the energy. And if it is moving from outer to inner, then it is releasing the energy.
Energy.
Okay, so you have to make this diagram. This second diagram you have to make, okay? Write these 3 points. Niels Bohr in 1912. Note out these 3 points and make the diagram also. This diagram. Electron energy change. Noted?
No, sir.
1 minute, I'm drawing the diagram.
Yes.
Okay.
I'm sorry.
Done? You
No, sir.
also? Yes, Rumaisa, tell me that what was the assumption of Bohr model? What was
Can
the
you repeat the
assumptions?
question?
What was the assumptions of Bohr model? What he said, he modified this atomic structure. So what he said actually in his model?
He says that only certain special orbits, known as discrete orbits of electrons, are allowed inside the atom. And while revolving in discrete orbits, the electrons do not radiate energy, and energy is emitted or observed by an atom only when an electron moves from one orbit to another.
Okay. Yes, tell me. Yes, Avni, tell me that if the electron jump from inner orbit to outer orbit, will it radiate energy or will it lose energy? Sorry,
It'll
gain energy.
it'll absorb energy.
Okay. If it is moved from it may when it is moving from one orbit to another orbit, it may either lose or gain energy. Okay.
Yes.
So when it lose,
From outer to inner.
okay. And yes, Urias, when energy is being released,
Inner to outer.
outer to
So I have to say
inner.
this.
Yes, you Abdul Jabbar, when energy is being absorbed,
Yes, sir.
when energy is being absorbed by the electron, when it moves from
Sir, inner to outer.
inner to outer orbit. Okay. Next is atomic number. Atomic number. Atomic number is the total number of electron present in an atom. Okay. Uh, total number of electron or proton present in an atom. That is called atomic number. Okay. So note it down. It is the total number of proton. Proton means that is present in the nucleus. Proton. Actually, proton in a neutral atom, which is not having charge, proton number of proton is equals to number of electrons. Okay. So if we have 5 proton, then we will have 5 electrons. So we can say that atomic number is the number of proton or electron present in an atom. Okay. Actually, neutron is present in the nucleus. So sometimes the atoms can lose electron, but proton cannot be lost. So that's why we specifically write the number of proton. present in the nucleus of an atom is called its atomic number. Okay, and no two different elements can have the same atomic number. Two different elements can have same mass, but they cannot have different atomic number. Okay, if they, for example, if this is carbon 14 and this is nitrogen 14, they both are having same mass, but they are having different atomic number. It is going to have 6 atomic number, it is going to have 7 atomic number. Okay, and if they are the two different atoms, like you imagine, this is carbon 12, 12 and carbon 14, but they are going to have the same atomic number, so they are same elements. If they are having same atomic number, they are same elements. Okay, if they are having different atomic number, they are different elements. Okay, they are different elements. You understood? Same atomic number means same element, whether they have different mass. Different atomic number means different element, whether they have same mass. Same mass, but different atomic number means different element. Different mass, but same atomic number means same element. Got it? So make this one also and write this point. The total number of proton present in the atom. This one, the whole. Note it down. The second one is an atomic number is the identity. That's why atomic number is the identity of an element. No two different elements can have same atomic number. Carbon, nitrogen, fluorine, bromine, iodine, sodium, they all have different atomic number. So two different atoms will have different atomic number. That's why it is the identity and it is always lie in whole number. Like in mass, we can have 35.5 in chlorine. The mass of chlorine is 35.5. Okay. 63.5 for copper. There can be different mass in decimals also, but atomic number is always in whole number because it is the number of proton. Proton cannot be in decimals. It can be either 1 proton, 2 proton, 3 proton. An atom cannot have 2.5 proton. Got it? Are you getting my point? Are you getting my point? So atomic number is denoted by Z and it is always in a whole number. It is always in a natural number. It is always a natural number. Means perfect number. Whole number. Atom cannot be in decimals. Sorry, atomic number cannot be in decimals. Like the atomic mass an atom can have atomic mass in decimals, but it cannot. Next is for a neutral atom, the number of proton is equals to number of electrons. So note all these 3 points. The whole atomic number points noted down in the copy. Done?
Yes, sir.
Yes, sir.
Yes, sir.
Noted? Everyone? Riyaz, you
Yes,
done?
Yes, sir.
Okay. Can you tell me that what is the atomic number? Can two different elements have the same atomic number? Can two different elements have the same atomic number? Riyaz, tell
No.
me. Okay. Yes, Avni, tell me. In a neutral atom, number of electron is equals to?
Huh?
In a neutral atom, number of electron is equals to number of?
Number of electron is equal to number of proton.
Okay. Is the atomic number can lie in decimal? Yes, sir. You Abdul Jabbar. Is the atomic number can lie in decimal?
Natural number.
Tell me, yes or no?
No, sir. It's always a natural number.
Okay. Can you tell me? Yes, you, Riyaz. Tell me that is the atomic number or atomic mass? Which is the identity of an atom? Identity, atomic number or atomic mass?
Atomic mass.
Atomic number.
Oh,
Identity
number,
means.
number. Yeah.
Tell me that if the two elements have different atomic number, will they be same element or different? Can they be same if they have different atomic number? Tell me, Riyaz, if the two elements have different atomic number but same mass, different atomic number but same mass, will they be considered as same element?
No,